Hey everyone, welcome back to the channel. Today we are diving into an exciting new project, an ultrasonic radar system using Arduino. This radar is packed with awesome features. It detects obstacles, display distance and temperature, and even has a dynamic radar sweep animation on an OLED screen. Stick around as I break it all down step by step so you can build this yourself. Let's get started. In this project, we are bringing together powerful components to create an interactive radar system. Let's take a quick look at what we will be using. First up, we have the Arduino UNO, the brain of our project responsible for processing all the data. This microcontroller acts as the central hub. For visualization, we are using a 0.96 OLED display, which brings the radar scan animation on the display. Then there's the ultrasonic sensor, which detects obstacles by measuring distance. It's mounted on an ultrasonic stand to hold it securely in place. To monitor environmental conditions, we are using the BMP180 sensor, which provides temperature, pressure, and altitude readings. A servo motor will control the sweeping motions of the radar, while a buzzer will trigger alerts when obstacles are detected. You need a bunch of jumper wires to connect all the sensors to the Arduino UNO. A buzzer serves as an alert system producing sound notification when an obstacle is detected within a certain threshold. We are using two lithium-ion batteries as the power source for our system. Now that we have our components ready, let's jump into the code and see how it brings this radar to life. Before we dive into the code, let's get our development environment ready. First, download the Arduino IDE from the official website and install it on your computer. I have already got it my setup, so we are good to go. Next, we need to install the essential libraries. One is Adafruit SST1306, which is for OLED display, and another one is Adafruit BMP085 for the temperature, pressure, and altitude sensor. I have already installed these libraries, but if you have not, you can easily add them using the Arduino Library Manager. Now let's make sure we have selected the right hardware. Go to the tools, select boards and select Arduino UNO to match our setup. Now that we have covered the hardware, let's dive into how these components work together to create the radar system. Connect your Arduino UNO to your computer, then select the correct COM port. Click the upload button to transfer the program to the board and begin execution. After clicking upload button, wait for a few seconds while the Arduino IDE compiles and transfers the code to the board. You will see a progress bar indicating the upload status. Once the upload is completed, you should see a done uploading message in the IDE. In this video, we are using a plain cardboard base to mount all the components properly. Secure the ultrasonic sensor stand onto the servo motor shaft, ensuring it is firmly mounted. This setup allows the servo to rotate the sensor smoothly, enabling the radar system to scan the surroundings effectively. Make sure the stand is properly aligned and balanced to avoid any instability during movement. Now that we have seen the components, let's wire them up and understand how they work together. First, we have the ultrasonic sensor. The trigger pin connects to D3 and the echo pin goes to the D2 pin. This sensor sends out ultrasonic pulses and listens for the echo signals, allowing the Arduino to calculate distance based on the time it takes for the signal to return. For environmental sensing, we are using the BMP180 and OLED display. They communicate with Arduino via I2C protocol using A4. The A4 is connected to SDA and A5 is connected to SCL on the Arduino UNO. The BMP180 gathers temperature, pressure, altitude data, while the OLED display brings it all to life with a radar animation. With all these components working together, the system detects obstacles, gathers environmental data, and visualizes it in a radar-style display. Now the servo motor is connected to D9 pin. The motor controls the sweeping motions of the radar, helping scan the environment. We also have the buzzer, wired to pin number D8. This will produce an alert when an object is detected with a certain range. Finally, I have connected the power supply to the Arduino board. The positive terminal of the battery is connected to the Arduino VCC pin, while the negative terminal is connected to the ground pin. This ensures stable power delivery to all the components, allowing the radar system to function smoothly without needing a constant USB connection. To keep everything organized and stable, I will use a plain cardboard base to mount all the components properly, to ensure a clean setup and prevent loose connections during the operation. As you can see in this video, when an object comes close to the ultrasonic sensor, it triggers a warning sounds through the buzzer, alerting us to the detected obstacle. Simultaneously, the servo motor continuously rotates, allowing the radar system to scan the surroundings in the real time. This movement ensures the sensor covers a wide range, accurately detecting obstacles from the different angles. The OLED display shows temperature, pressure, altitude, and distance readings along with a smooth radar animation for real-time obstacle tracking. That's it for today's video. If you like this video, give it a thumbs up and subscribe for more cool tech projects. Let me know in the comment section below how did you improve or use this radar system. Thanks for watching.